All right, so this is going to be your quick quiz review before you go ahead and take the quiz. Remember, this needs to be watched, the quiz needs to be completed, and 2.4 video notes need to be completed before the end of the block. Your 2.4 homework will be due Sunday by midnight. Let's go over a quick quiz review here. 2.1 through 2.3. We started with conditional statements, which were if-then statements. So if we have our if-then statement, we had a little bit of confusion with recognizing our hypothesis and conclusion at the beginning of the week. Okay, remember your hypothesis is anything after the if, so two angles are complementary would be our hypothesis. If is not included in it. And then your conclusion would be anything after the then. Okay? So they add to 90 degrees. Then is not included in the conclusion. All right? So from that conditional statement, we came up with our inverse, our converse, our contrapositive, and biconditional statements. Who remembers what we did to find the inverse? Okay, what do we do to the statement to get the inverse? We negate it or add not. So what's that going to sound like? Okay, if two angles are not complementary, then they do not add to 90. Okay, what did we do? We added not to our hypothesis, we added not to our conclusion. Converse. What did we do to find the converse? We flip it. It means we take our conclusion and put it first, take our hypothesis and put it second. So what's that one going to sound like? If my conclusion is they add to 90 degrees, so if two angles add to 90, then what's the hypothesis? They are complementary. Okay, we just flip-flopped our hypothesis and conclusion. Contrapositive. What do we do for the contrapositive? We flip it and add not or negate it. What's that going to sound like? Remember, come from your original statement, so we're going to flip it and add not. So if two angles do not add to 90, then they are not complementary. Okay, biconditional. What do we do to the statement for biconditional? Or what words would be in the statement to help us recognize that it's a biconditional statement? What do we look for? That one we look for our if and only if. Okay? Remember, the biconditional, we take the hypothesis and conclusion, take out the if and then, and put if and only if between them. Okay, so what's that going to sound like? Two angles are complementary if and only if they add to 90 degrees. Okay, now with the biconditional, something else was important. What two things have to be true to make the biconditional statement true? Okay, so think about what four things we just talked about. We have our conditional, our inverse, our converse, and our contrapositive. Which two of those have to be true to make the biconditional true? The conditional, the original, okay, and its converse. The conditional and converse have to be true to make the biconditional true. All right, so from that, we started applying all of those words with the sentences to symbols. So P could represent the hypothesis, Q could represent the conclusion, or it could be other variables. And then we could, instead of writing sentences, we put it in symbols. So a couple of the symbols, just for a refresher, one of them was a squiggle in front of P. Okay, what did the squiggle mean? The squiggle meant we negated it. So this would be not P. Or if P represented our hypothesis and Q represented our conclusion, that would mean not P. So two angles are not complementary. Okay, what else did we have? If we had this guy, how would that really read? Okay, what's the arrow do? That makes it the if-then statement. So this one would be if not P, then not Q. Okay. One other symbol that we need to recognize would be the crazy double arrow. What did the double arrow mean? The double arrow was our biconditional. So if and only if. So P if and only if Q, or two angles are complementary if and only if they add to 90. Okay, so that kind of covers our symbols. The only other two things that were in 2.3 were law of detachment and law of syllogism. So let's talk about those real fast. Law of detachment, remember, gives you an if-then statement. And then for your second statement, it applies the hypothesis. Okay, it has to apply the hypothesis. It cannot apply the conclusion. So if we have the statement, if it is storming, then it is cloudy. Our second statement says, today it is storming. Well, our hypothesis was, if it's storming. Our second statement is applying the hypothesis. So I'm saying, well, today it's storming. So can I assume that it's cloudy? Yes, by the law of detachment. I applied the hypothesis, which means I can assume to be that conclusion to be true. But let's look at the opposite of that. So if I look at the second one over here on the right, I have, if it is storming, then it is cloudy. Then I tell you, today is cloudy. Well, if today's cloudy, the hypothesis was if it's storming. So if today is cloudy, I'm applying the conclusion. That's a problem. So that right there would say this is invalid. This is invalid, okay, because it's applying the conclusion. Law of detachment does not work. Now, anytime we say something's invalid, we need to come up with a counterexample. When we come up with that counterexample, that's any example that makes the statement false. So if it's storming, if I tell you that today's cloudy, does that mean it has to be storming? If today is cloudy, does it have to be storming? No. What are some other examples when it's cloudy? Well, it could be cloudy and it could be raining. It could be cloudy and it could be snowing. It could be cloudy and it could be just cloudy. The sun's just not out, right? So all of those would be counterexamples because all of those are examples when it's cloudy but not storming. Law of syllogism is a little bit different. With law of syllogism, we're given two if-then statements and then we come up with a third if-then statement for our conclusion. So for this example, if we have, if you are a good student, then you will take geometry. If you take geometry, then you will have good grades. So law of syllogism says, if the first conclusion and the second hypothesis are the same, what we can do is assume that if you are a good student, then you will have good grades. Okay, so you can take the first hypothesis to the last conclusion. If you are a good student, then you will have good grades. This was the one where if we knew we went from P to Q, and then we went from Q to R, then we can say P to R. So these two guys have to be the same to get P to R. So here's my P, Q, Q, R. So then we went from P directly to R. Okay, so that was law of syllogism. So that pretty much wraps up this first couple lessons. This is what's on the quiz. So go ahead and take the quiz. Once you finish the quiz, go ahead and get your 2.4 notes done. I will be checking up on you guys. I will also be available on Remind Text or email if you have any questions. So feel free to reach out. Remember, the quiz is timed and there is no backtracking. So make sure once you open it, you get it done. All right, have a great day.